So this example 3, it says use your calculator table of values to find a limit. So we're taking it, I can read it like this. The limit as x approaches 0 of x over the square root of x plus 1 minus 1. Okay, this here, that's the f of x. But the table of values, here's the x, here's the f of x. Remember, when you do a table of values, you get to pick the x's. And they pick the x's. This is just coming straight from your book. Notice how they've got the numbers, 0 is in the middle, right? And our numbers are getting closer and closer to 0 as you step from here to here to here, right? Negative 0.01 to negative 0.0001. They're getting closer to 0. Right? What's happening to the value of the function as it gets close, as the x's get closer to 0? 1.995, 1.9995, 1.999. It's getting closer to 2. Okay. So what about for if I come in from the other direction, right? 0.01, 0.001, 0.00001. That's getting closer and closer to 0. What's happening to the value of the function? It's getting closer and closer to 2, right? So remember in the definition on the previous slide, it says as x approaches c from either side. That's what they mean by that. It has to be that, you know, when you approach from the left, right, it looks like it's approaching 2. When you approach from the right, it looks like it's approaching 2. So since it's approaching 2 from either side, then the limit is 2. You know, we will see examples later where that's not the case. If it doesn't approach the same number from both sides, there is no limit. It's got to approach the same number. Tiffany, yep. Tiffany, yep. Done? Okay. Now, oh, I'm still recording. I didn't know that. So I'll tack this onto the end here. Now, look, that's our function, right? What is the actual value of the function at x equals 0? I mean, what would happen if I plugged in x equals 0? I would get 0 over the square root of 0 plus 1 minus 1, which is 0 over the square root of 1 minus 1, which is 0 over 1 minus 1, which is 0 over 0, which is undefined. Right? So the function is not even defined at x equals 0, but it still has a limit. Right? Just like the slope would not be defined if I let those 2 points get to come together, but there is still a limiting value of that process of letting the points come close together, or letting the number of rectangles approach infinity. Right? We can never let the area of the rectangles go to 0, or else we would have no area. So that is expected. It's almost the whole reason why we're doing this. That the value of the function at that value, the c, right, it actually doesn't have a value, but it still has a limit.